Hi everyone. So in our last video, we talked about graphs of functions, and we talked about the relationship between the formula for a function and its graph. And one of the things we learned is that if you have the formula for a function and you want to sketch its graph, one thing you can do is make a table, right? You can list a bunch of different x values and calculate what are going to be the outputs. And then once you have all of those inputs and outputs, you can plot those as points and connect them to get the shape of your graph. So that is, one method that will always work for sketching a graph. However, you're going to find it really useful, both in this class and in future math classes as well, to have some basic familiarity with some specific examples of functions. So that's actually kind of one of the main, I'd say, big topics of this class is becoming familiar with the graphs of different types of functions so that you have methods for graphing them that doesn't rely on just making a table every time. And the reason it's important is basically when you get into, especially I'd say calculus classes, you're going to be expected to be familiar with certain graphs. You're going to be asked to, do certain things with functions that relies on you knowing what their graph looks like. And it's really going to slow you down if every single time you have to just make a table and plot points. So like I said, in this video, we're going to be focusing on some of those special types of functions whose graphs are really important. So graphs that you should know. So first type of function we're going to focus on is a function where the equation looks like f of x is equal to mx plus b. So in this formula, m and b represent numbers, like fixed numbers. So for example, you could have like f of x is equal to 2x minus 3 would be an example. So x is the variable, m and b just represent numbers. So this is a function that I'm hoping most of you are familiar with. This is definitely something that you're supposed to have learned in your previous math classes. So this is what's called a linear function. So why is it called a linear function? Well, because its graph is a line. So I'm just going to kind of sketch an example of what a linear function might look like. So we can get a little bit more specific here. So the number m, this tells you the slope of the linear function. And by the way, we're going to actually have a whole, probably 2 videos or so devoted to linear functions a little bit later. So we're going to go over linear functions in a little bit more depth. This is just kind of a quick reminder about how they work. So the slope refers to basically how steep the graph is. One way of calculating the slope of a graph is that if you take 2 points that lie on your graph and you see how far between those 2 points, how far do you have to go up? So that's sometimes referred to as the rise. And then how far do you have to go over? And that's sometimes referred to as the run. And so slope can be calculated as that vertical change, the rise, over the horizontal change, which is the run. So again, I think most of you have seen this before, so hopefully you remember how slope works. The other thing that we can get out of this equation is b. So b gives us the y-intercept of the graph. And so what is the y-intercept? It's just the point where the graph crosses the y-axis. And so this point that I just highlighted in blue, that's the y-intercept. So the x-coordinate is going to be 0, and then the y-coordinate is going to be whatever that number b is. So yeah, the idea is that if you're asked to graph a linear function, you shouldn't have to make a table. You can basically just start by graphing the y-intercept, and then you can use the slope to figure out another point on the graph and then go from there to sketch the graph. Okay, so this next one is kind of, it's related to linear functions. So the next one I want to talk about is now something that's of the form f of x is equal to b. So again, here b just represents a number. So an example of this could be like f of x is equal to 5 or something. And maybe actually, let me go back and just put an example. So I'll put an example of what these could look like for each one. So an example of what a linear function could look like would be f of x is equal to, let's say, I'll say something that looks like it could match our graph. Let's say 2x plus 1. Okay, so f of x is equal to b. So what I mean by that is some kind of function that maybe looks like, I don't know, f of x is equal to 5, or f of x is equal to 3, or f of x is equal to -7. So it's just f of x is equal to a number. And so this type of function is what's called a constant function. So why is it called that? Well, basically because the right-hand side of this equation is constant, right? It doesn't change. If your equation, for example, is f of x is equal to 5, no matter what number you plug in for x, your output is always 5, right? F of 1 is 5, f of 2 is 5, f of 7 is 5, f of 100 is 5. No matter what the input is, the output is always 5, and so it's a constant. And so what does the graph of this look like? It looks like a horizontal line, because again, the height doesn't vary. The height is always the same because the output is always the same. And specifically, it's going to go through a height of b, right? So this actually also has a y-intercept of 0b, because that's the height that the graph is fixed at. Okay, I'll just go down. Let's look at the next one. So the next type of function I want to talk about, and this one we're going to spend a little bit more time talking about. So next type is a function where you have x raised to some number n. And specifically here, when I write n, n represents a positive whole number. So an example of one of these functions could be something like f of x is equal to x cubed, or f of x is equal to x to the 4th power. Those are examples of this type of function. And so this type of function is what's called a power function. And so it's called that because you're taking x and you're just raising it to a power. So I want to take a moment to explore what the shapes of these graphs look like. So I'm going to pull up Desmos. And I encourage you, if you have a smartphone, to get the Desmos app or go to the Desmos website and kind of follow along and see if you can also pull up these graphs on Desmos, because I think Desmos is a really good tool, and I like to take an opportunity to basically make sure you're familiar with how to use it. So I already typed in a bunch of different equations here. So I'm going to start by pulling up x squared. Okay, so x squared looks like this. It's a parabola. This is a graph that, again, I think probably a lot of you are already familiar with from previous classes. So now I'm going to pull up x cubed. So that's what x cubed looks like. Now I'm going to go to x to the 4th. Now I'm going to do x to the 5th, x to the 6th, x to the 7th. So I want you to think for a moment, what are some similarities or differences that you see in these graphs? So again, x squared, x cubed, x to the 4th. I'll pull them all up at once, even though it will kind of look crazy. So, what are some similarities and differences you're seeing in the shapes of these graphs? So one thing you might have noticed is that depending on whether that power is an even number or an odd number, that's what determines the general shape of the graph, right? So I'm going to pull up only the even graph. So we have x squared, we have x to the 4th, and we have x to the 6th. Notice that they all have this kind of U shape. So by the way, the word parabola is really technically only used for the graph of x squared. So for quadratic, we'll get into that topic later, but for functions where x is being squared. So technically the graphs of x to the 4th and x to the 6th, those are not actually called parabolas, but they have a similar shape to a parabola, right? They have this kind of U shape. So why is it that all of these graphs have this like U shape to them? Well, if you think about it, when you take a number and you raise it to an even power, no matter whether that number is positive or negative, you always get a positive result, right? So let me just, to make this less overwhelming, let's focus on x squared. So for example, if you plug in +1 and square it, you get positive 1. If you plug in negative 1 and square it, well, you also get positive 1. And similarly, if you plug in positive 2 and square it, you get 4. If you plug in negative 2 and square it, you also get 4. And so the same thing happens with raising something to the 4th power or raising something to the 6th power. Anytime you're taking a number and raising it to an even power, it's always going to give you a positive result, because basically a negative times a negative is a positive. That's really the main thing that's going on here. And so that's why the graph goes up on both the left and the right. So we'll come back to the odd ones in a second. I just want to start by sketching a graph here. So basically, anytime you have x to the n, where n is an even number, your graph is going to look something like this. So this is what the graph will look like if n is even. Okay, so what about the other ones? So the ones where n is odd. So that's cubed. Here's the 5th power, and here's the 7th power. So these all have a different kind of shape, right? They have a shape where they go up on one end and down on the other end. So why is that? Well, it's basically the same kind of argument that we talked about for the even one. So let's look at x cubed for a second. So what happens when you take a number and cube it? So maybe let's talk about 2. So if you take positive 2 and cube it, that means you're doing 2 times 2 times 2, and so you get 8. Now, what if you take negative 2 and cube it? Well, that's negative 2 times negative 2. Negative times negative is a positive. But then you multiply it by negative 2 again. And so that actually gives you negative 8. And so the difference is that if you take a number, a negative number, and raise it to an odd power, it's always going to give you a negative result. And so that's why these functions go down on the left side, because when you're plugging in a negative result for x, you get a negative result as your output. And so that's really the reason that these graphs look the way they do. And so if n is odd, the shape is generally going to be like this. Okay. And let me just, while I'm on Desmos, just show you a couple of other things. So I just want to show you kind of like how you would do this from scratch. So I'm just going to go back to regular Desmos here. When you first pull up Desmos, the default is that it counts by 2s. Personally, I kind of prefer to have it count up by 1s. So if you go to this settings button, and then you click on where it says step, you can change that. So I can change this to being a step of 1. And here I can also change this to being a step of 1. And then personally, I also tend to like to get rid of these smaller grid lines, because I think they just kind of make the picture look more overwhelming. So you can do that by clicking where it says minor grid lines. And depending what you're doing, you might want them on, you might want them off, but there's an option for either one. Yeah, that's basically all I think I wanted to show you here. I guess one other thing to mention is that in order to get the exponents, the way that you would do it on a computer is you would type the little like caret button. So you would type, f of x is equal to x, and then you would use, where is it? Sorry, just look at, here, this button here. This is the button that would allow you to then type in an exponent. It's a little bit different on smartphones, so it probably will take you a little bit to get used to how it works on the smartphone. I personally think it's a little nicer on a computer than on a smartphone, just the way things work, but yeah. Okay, so that's power functions. And I would say, by the way, that the two graphs, so I would expect you for power functions to know that, if n is even, it looks like this. If n is odd, it looks like this. And then the two that are most important to know for this class are x squared and x cubed. So those are graphs that I expect you to be kind of extra familiar with. And I actually ask you on the worksheet that goes with this video to sketch those two graphs so that you can get a little bit more familiar with the specific points that lie on them. Okay, so next one we're going to look at is in some ways kind of the opposite of the ones that we just did. So these next ones are functions of the form f of x is equal to x to the 1 over n. Or another way of writing that would be, actually, let me write this below. Another way of writing that would be the nth root of x. So for example, an example of this type of function would be f of x is equal to x to the 1/3. So another way of writing that would be saying the cube root of x. So we'll probably write them either way. It turns out in Desmos, it's a lot easier, or I think it kind of only allows you to type them in like this for the most part. But you should be able to recognize what it means either way. So 1 over n is just saying the nth root. So these functions are called root functions because you're taking a square root or a cube root or fourth root or fifth root. And actually I messed up and I need 2 pictures here, just like with the last one. So bear with me for 1 second. Just going to set this up. Okay, so let's go back to Desmos to see what these graphs look like, because just like with the other ones, the shape of them is going to depend on whether n is an even number or an odd number. Okay, so I have these ones pulled up as well. So let's start by looking at the even ones. So here I have x to the 1/2, so that's the square root of x. I have x to the 1/4, that's the 4th root of x. And then I have x to the 1/6, and that's the 6th root of x. So notice that, and actually let me focus first just on the square root of x. So basically, what does the shape of this look like? It looks like you took a parabola, so let me go back to the parabola, and turned it sideways, but only took the top half of it. So it's basically like the top half of a sideways parabola. And so we'll get a little bit more into this in a later section in the book, but the reason that you only have the top half is that when you take the square root of a number, your answer is always positive. So for example, the square root of 4 is 2. So if you plug 4 into the square root function, you get 2 as your output. You don't get -2. Or the square root of 9 is equal to 3. It's not equal to -3. It's just equal to +3. And so that's why you only have this kind of positive half. The other thing I want you to notice is that there are no negative numbers included as your x values on this graph. So why is that? Why don't we have any negative inputs? Well, for a square root function, we know that you can't take the square root of a negative number, right? So it doesn't make sense that you could have a negative input. So for example, if you tried to make your input -4, that would mean you'd be taking the square root of -4, and that is undefined. So there's kind of 2 different things going on here. One is that you can only plug in positive numbers or 0. And so that's why the graph doesn't exist on this negative half of the x values. And then the other thing is that when you take the square root of a number, your answer is also positive. And so that's why the outputs are positive. That's why we don't have any negative outputs. So there's kind of 2 different things going on. And then basically the same idea works with the 4th root and the 6th root. So yeah, if you understand why you can't take the square root of a negative number, it's the same reason that you can't take the 4th root of a negative number or a 6th root of a negative number. It's because raising something to an even power always gives you a positive result. And so you can never take an even root of a negative number. Okay, so let's go back to our notes here. And so what we just saw is that if your n value is even, then your graph is going to look something like that. It's going to look kind of like half of a sideways parabola. Okay, so what about if n is odd? So that would be x to the 1/3, so that's the cube root. I also have the 5th root, so that's x to the 1/5, and x to the 1/7, that's the 7th root. So notice that these ones basically look just like the graphs of x cubed, x to the 1/5, and x to the 1/7, but they're just sideways. Again, that's something we'll get more into when we get into a section about inverse functions. We'll really talk about the relationships between the power functions and the root functions. But yeah, basically, why is it that these graphs do include the negatives? Well, let's focus on the cube root first, because I think that's the easiest one to understand. So for example, you can take the cube root of -8, right? What's the cube root of -8? It's -2, because -2 cubed is -8. And so unlike square roots, cube roots, you can take cube roots of negative numbers, and your answers can also be negative. And so that's why unlike the square root or fourth root or sixth root graphs, the cube root graphs do include negative x values and negative y values. And so same thing goes for the fifth root or the seventh root. So let's go back to our notes here, and we can say that if n is an odd number, then your graph will look kind of like this. So again, just like with the last one, I'd say that I would expect you to have some general familiarity. Like I would expect you to be able to, like multiple choice, know what the graphs look like, the general shape for even and odd. The specific ones that I would want you to be like extra familiar with would be the square root and the cube root. Just like how with this last one I said, really the two graphs I want you to really know are x squared and x cubed. Similarly here, I would want you to know square root of x and cube root of x. Okay, so let's look at one last type of function. So this one's a little bit, I'd say in some ways less important than the other ones, but also good to know. So that is the absolute value of x. Okay, so what does the absolute value graph look like? Well, it basically has a V-type shape. And we're actually going to talk a little bit more about this graph in the next video, because in the next video, we're going to be talking about graphing piecewise functions. And if you recall, the absolute value function actually can be written as a piecewise function. So we'll talk about how to understand it that way in tomorrow's video or in the next video. But briefly, why does the graph look this way? Well, remember that when you take the absolute value, it always makes your result positive. So if you plug in a positive number, like let's say you plug in +1, the output is going to be also +1. So you have the point 1, 1. On the other hand, if you plug in -1, well, then your answer is still positive. And so basically, that's why you have this kind of symmetric shape on both sides, where no matter what value you plug in for x, whether it's positive or negative, your result is always positive. And so that's why the graph kind of flips upward on the negative side of it. So yeah, that's actually it for this video. And like I said, I think it's really important that you do the worksheet for today, because I asked you to actually go through and really specifically graph some of these. And I asked you on the worksheet basically to focus on the ones that I think are most important that you're familiar with. All right, I will see you all in the next video.